So anybody and everybody who wants to know more about Cassandra API that we have just GA'd, and there are hopefully, I think I don't see, yeah, there are some customers also who have actually adopted and made it successful. So what I wanted to do today is make sure that you understand what we have GA'd, what do we have, and go ahead. Let me see if it works. Okay. So there are a few things that we're going to do. We're going to look at Cosmos DB overview. We're going to look at what Cassandra API brings to the table and do a bunch of demos, which should be very simple. Our goal is to make, or my goal at least, is to make sure that when you walk out of this room, you are confident handling any Cassandra workload without all the overhead that you normally associate with Cassandra, right? We'll also look at our costs, and we'll look at what does it require to take advantage of the Cassandra API. But before I go, since we have such a large audience, how many of you actually use Cassandra API? I guess not many. Okay. Oh, there you are. Oh, okay. Okay, that's okay. Thank you. So, so the first part is what does Cosmos DB itself, right? So let's come to that part. This is very important to understand the overall Cosmos DB. So how many of you use Cosmos DB? At least some of you. So thank you very much. It's the customers like you who have helped us to take these bold bets further ahead. So there are a few basic things to understand in terms of why Cosmos DB and what is the problems the Cosmos DB really resolves, right? If you really see, the fundamental of Cosmos DB are based on providing you availability guarantees. Why? Why is the question? Or we say basically the total global distribution. Why, right? So if you use Oracle, SQL, or even a NoSQL system, where do you spend most of your time? Okay, let me help you out. I think you know the answer. There are 2 or 3 places that most of the database folks spend a lot of time. One is providing availability. And availability basically simply means that the system should be highly available regardless of whatever is happening in the backend. That also means that that has also a connotation in terms of providing the data access where the customers are. So what we have done is we provide 5 nines for reads and writes as of this week without you having to do anything at all. Okay? This also means that your clients are auto-homing. If the region goes down, they will automatically fail over to the next region if at all you choose to do so. Okay? Compare this with any other database system. This is a humongous leap from where you are. Okay? Second place, where do you spend time? Right? The second place that where we spend time is, let me take a guess again. Hopefully it is the same thing. When you embark on a new database project of any kind, relational or non-relational, capacity planning. Capacity planning in terms of throughput, capacity planning in terms of storage. Cosmos DB again makes it completely non-issue. You just come in and tell us how much throughput you need. You have unlimited storage, and your throughput can be varied up and down. Okay? This is very important. Let's say there is a need for higher throughput for doing ETL. There is a need for higher throughput in some retail scenario or some IoT scenario. You don't need to set up machines, nodes, make sure the data is available in those things, those nodes. The throughput is instantaneously available, and that's the key part. And you can instantaneously bring it down n number of times through the day. Right? So that's the second problem that we take care of. The third issue is, let me take a guess again, since performance, right? Performance of individual reads and writes. All database professionals, regardless of the database, we all spend time on index management. We all spend time on making sure that we provide right kind of hardware to do the writes fast, right? And many of us actually even know how to format a disk with a particular block size to get the advantage of the writes and so on and so forth. So what Cosmos DB does is, again, makes it completely non-issue. We provide you SLA-based guarantee of less than 10 millisecond of reads and writes across the world as of today, for 1 KB of data, of course. And this is important thing because you do not have to think about performance for individual operations at all. Okay? So this is the fundamental property of Cosmos DB. Today what we are announcing, or actually we announced in this week, is the GA of the Cassandra API. Right? Now, since many of you use Cosmos DB, how do we enable multiple databases on top of us? Right? So what we do is on the top of these fundamental capabilities, we expose the various data models. In each of these data models, we expose the various APIs. So when we started out, we had the document model and the key value model. We exposed MongoDB and the SQL API model. Then we exposed the table API and graph last year. And then finally today, basically this week pretty much, we have GA'd the Cassandra API. Right? So this is the key. You will see a lot more APIs coming in the future, but this is how we enable multiple APIs as we go along. Right? Now, what are we announcing? Right? So since this is, I'm going to fiddle around a little bit till I get comfortable. But what we are announcing is a cost-effective performant Cassandra API. What does that mean? That simply means that it allows you, we allow you today to bring your application as it is, which are written with CQL drivers. So whether you use Java, Go, C#, and so on and so forth, as long as they use a particular CQL compliant driver, you can basically make that program work against Cassandra API of Cosmos DB. So this is our basically the whole premise, what we have announced, right? So what you don't have to do? There are many things. I will walk through them. But what you get is basically SLAs for availability without you having to manage the nodes, manage the uptimes of the machines, OS, and so on and so forth. And you get unlimited basically throughput as well as elasticity of the storage whenever you require it. Right? Now, there is a specific line there which basically has some numbers. We basically say that there are 3 numbers there. So let me walk you through them, what each one of them means. So when a Cassandra is released, Apache Cassandra is in a TikTok fashion, it has 3 components. One is the binary protocol, for which we are v4 compliant at this point of time, with some minor things that we will implement as we go ahead. Then there is a query language, the actual SQL query language, for which we are at 3.4.4. And the actual Cassandra itself, the software itself, we are a drop-in replacement for anything which is 3.11 plus at this point of time. We have had customers who use vendor-provided Cassandra at a much higher level, but actually they are using only, the Apache Cassandra is only at 3.11 because that's the publicly released version at this point of time. The 4 is just about in process of basically getting out. You can basically have other versions of vendor-provided Cassandra. We will work with you. Majority of the things just work out of the box, even for non-Apache Cassandra. Okay? So you might, I think some of you are here, you might know there are some vendors, at least one vendor, who provides a commercially backed Cassandra offering. Right? So this is what we provide. Now, I requested how many of you use Cassandra, right? There is a reason why we did this. And the reason for that is, let me find out what is the pain for managing Cassandra, right? So if you're a Cassandra DBA, where do you spend your time? What you can do is you can go to the user mailing list. You can go to other places where people post their issues. If you are a Cassandra DBA, you have to do a lot of work. You need to know the JVM and GC settings. You need to know JMX settings. JMX settings are for monitoring. You need to know how to do read repairs or manage the read repairs. There are multiple tools to do that. End of the day, you are focused on you're focused on managing and operating a large system all by yourself without a lot of help. Right? There are many tools. You will have to spend time across multiple tools to manage a large Cassandra cluster. With Cosmos DB, what you do is you don't have to do any of these things. You don't have to manage JVM, you don't have to manage GC, you don't have to look at JMX, you don't need to do the YAML configs, pretty much nothing, right? So what do you do? So that's where we come into a bunch of demos now. This is going to take very short amount of time. I will walk you through all these, and I'm open to questions since there are not many people. So what I will cover is how to create a Cassandra account, how to query that account, how to increase or decrease the throughput, and hopefully, if we have more time, also look at the Spark connectivity and so on and so forth. Right? What you should get out of that whole demo part is how easy it is to provision, how easy it is to interact, and just make sure that you only focus on the application and not on the internals of the platform. Okay. So with that, I will do a switch here. And so there are two ways you can create a Cassandra account. One is, of course, using our portal. So I will definitely get into that. But other way is that you can always come to the PowerShell. Okay, let me just. Another way is basically use, if it is not visible, so just use PowerShell to create the Cassandra account, right? This is one way of doing this. We will have the CLI way to do this also, but this is already there, right? The other way would be you come to, and let me know if you can see or not see at the back end. Can you see the screen, or should I make it a little bigger? I guess I think I should make it a little bigger. Yeah. So it's very straightforward. You come in, choose Cosmos DB as one of the resources that you want to create. You provide the subscription information. You provide the resource. In this case, it is which is already existing. And this is, you provide the account name, okay, and choose the API. As you can see, there are multiple APIs. We have the SQL, we have the MongoDB table and the Gremlin, and we also have the Cassandra. And you choose the locations, right? So you can choose whichever locations which are basically available. If you are in government or if you are in sovereign regions, you will not see all these options. For obvious reasons, the data cannot come in or data cannot go out of any of these regions, those regions, right? Everything else is something that you choose to share. Okay, and what are these two settings? This is, you know that Cassandra already supports multi-master, right? It will allow you to write in individual locations, and it will resolve conflicts. So that is a capability which GA'd for overall Cosmos DB, where all the APIs of Cosmos DB are now multi-master aware. So Cassandra always had this property. We just enabled it. So it is a last writer wins for Cassandra. So that's one part. And the geo-redundancy is basically just to allow the failover in case you are really interested, right? So that's it, right? That is basically the key part. There are a few more things that you can do, which is important for some of our customers, and you can do all of this through ARM deployment also. You don't have to use PowerShell, or you don't have to use Portal. You can do all of this through ARM also, right? You can specify the virtual networks, you can specify the IP filters, and go ahead and create a new account. I have already created. It takes about 5 to 6 minutes to generally 5 minutes or less, but I have already created something. So let's go ahead and pick up that and see what happens once something is created. In general, what will happen is you will end up at a same portal experience that you have had for all the Cassandra APIs. What does it have? It has information. If you really see, you will have monitoring, you will have the settings, and you will have a data explorer. These are the key parts of our portal experience, right? Because in our case, once you provision, there are a few things that you can do. You can monitor, or you can change few of the settings. Here, what you will do is, and we will take one example, we will basically go ahead and add a table. Cassandra only requires table, right? So let's go ahead. This is a data explorer experience. You can create new key spaces or otherwise the tables themselves. Oops, that just gave me a minute. This is one way of creating the tables. I will also show you the other way, which is the SQL SH way of creating the tables. And the point of showing that is that anything which is SQL compliant will just work out of the box. So let's go ahead. You can choose the key space. And let's say T1, right? And what is the, I don't know whether everybody can see that, but I want to spend a few minutes here. What is this, right? If you are a regular Cassandra user, or for that, you would see this is the new thing that you need to learn here. What is this? This is basically the amount of throughput that you're requesting at per second level in Cosmos DB. Within Cosmos DB, all APIs require you to provision certain amount of throughput. What is this throughput? This throughput is basically number of operations, CRUD operations that you do against a particular API at a per second level. This is literally the currency that you buy from us at a per second level, and you provision that at that level. You can, and I'll show you later, you can, here we show it can go up to, you can provision up to million, but if you need 5 or 10 million, you can just contact us, and then we can enable that for you. So it's not an issue. So in this case, I think at this point of time, because it's a demo, I'll just go ahead and create this. Okay, let me get my power cable too while it is happening. Okay, so with that in place, and okay, so now this table is created. What can you do with it, right? So what you can do is you can do obvious things. Is basically insert data inside it. Yeah. Oops. Okay, thank you. I think it was, yeah, thank you. So you can add, so this is still under, so this, as you might have seen, if you use Cosmos DB, this is our data explorer experience. This is same across many of our APIs, and it changes the flavor based on the API. In the graph, you will see a little different interface. In our table, you will see a little different interface, and in our MongoDB API, this will be a little different interface, right? So this is pretty much, this allows you to know, I think generally people don't use this. This is just for the making sure that you get comfortable with it. But let me show you where you would possibly use this from, right? So the other way to interact with any Cassandra account, any Cassandra cluster is SQL SH tool. That's a tool which comes automatically with every Apache Cassandra distribution. It is present in the bin directory, and you can interact with our Cassandra API account through that particular tool. So how do you interact with it, right? So normally what will happen is you will go ahead and you will get a connection string information. This connection string information is present here. How do you connect to a Cassandra API account? It has a port, it has a username, password, and it has, of course, the contact point. This is a terminology mostly of the Cassandra world. So let's see what we can do with that part, right? So let me pick up this piece. So generally, if you are a little stuck, you can come here. We provide various ways or various SDKs, how they can connect to this particular account, all the information here, right? So in this case, I will pick up this information. Okay, and this is already available here. So let me just go ahead. I think it should be there, yeah. What does it require? It requires an endpoint information, it requires a port information, it requires user and a password, and that's basically it. Right? Now you're connected via SQL shell. Now this is an important thing. So this basically shows you that if you have a SQL compliant application, which in this case it is, it will just work. Okay? So what can we do here? So first thing that we can do is I have a little cheat sheet here. I will just use that rather than trying to create everything. So let's create a new key space, something very similar. There we basically combine the experience of creating a new key space and a table. Here we have to do a little different way. That's okay. And then you can create a table. Notice one thing here. I'll show you once I execute this. So it is created. Notice one thing here. You can see that it has got this extra parameter which is called Cosmos DB provision throughput. So this is the new parameter that we have enabled, which is valid only in case of when our accounts are in a place. There is no code change for the SQL SH. This just works out of the box. If you provide this parameter, it comes on the wire and as an extra payload, and we can get this information, right? So once it is done, of course, what can you do? You can insert data into that. You should be able to select, and let's make it where user ID. Right. So of course we can go here and see whether all those things are there. Let me just verify, just get the portal up. I just have this bad habit of always refreshing. Hopefully you guys don't mind. Right. And I think it was GSK3 and it was the table, this particular table. You can execute queries, SQL queries. By default, it will try to execute everything and it will show data. That's the same data that we entered earlier, right? You folks are still there with me? Everything is still simple. Compared to, let me contrast this with a Cassandra cluster creation by yourself. What would you have to do? Anybody? Anybody has done? So let me just lay out, right? You need to think of how to do seeding. You need to think through how to do token assignments, right? You need to think through whether to add serially, parallelly, or in a streaming way all the nodes, because if there are a bunch of tokens, then how do you assign them all? Can they come one by one, or can they come parallelly, right? These are the basic set of things. What else that you need to do? Anybody take a guess? Okay, the other guess, so let me help you out. If you have managed or want to manage Cassandra cluster, what you need to do, you will need to go to YAML files. You need to modify those settings. You need to modify the logging settings. You need to add monitoring into JMX or some other kind of tool, right? There are a bunch of these things that you need to do even before you get started up. Of course, you don't have to forget, you cannot forget the JVM and GC, right? You have to choose the right JVM and right GC with the right setting of the GC. And then you need to monitor the GC and JVM world too, right? So there are multiple set of things that you need to do. Hopefully, this experience shows you that this is just straightforward. You don't need to think of all those things, right? This is the key part, hopefully you take back from all this, right? So what else? So after this, what are the things that we can do, right? Let me just switch back to the presentation and let me just see what all we have covered. We have covered the portal-based access, account creation. Now let us look at, there is a tool called as Cassandra Stress. I'm assuming some of you might have used it. Of course, that also works out of the box, right? What can you do? I can go here. I need to quit this, and I need to go back here to tools, and you will see the Cassandra Stress here, right? And it will work too. And in the interest of time, today I will just show you what it requires. It requires basically again an endpoint. It requires a port. it requires information about, there is one extra thing. If you are on Windows, you need to provide a certificate information, right? If you are on Linux, you will provide similarly a certificate information, not a big deal, and the password and so on and so forth, and it just works, right? So let's go ahead, and that will go on, right? It will take less than a minute to basically set up, and that is it. It starts off, right? By the way, this is how one of the ways that we do stress testing for our tool, because some customers do use this as a tool to verify the performance. Okay. So hopefully everybody is still there. Okay. Now let us switch over to what does this mean, right? What is the scaling of throughput? Now remember, let us imagine a scenario, two different kind of scenarios. You are a retailer. You basically have a Black Friday coming on. You need extra throughput than normal. What would you have to do in normal world? You would have to add nodes. You would have to add wait for the data to catch up and basically declare this particular node is now ready to take the workload, right? What do you need to do in Cosmos DB side of the things, right? First thing, of course, you can go to the portal and do everything. I will show you how you can do through SQL/SH also, right? And how is that? So what you can do is, I'll show you both the things, but let me just pick up this piece. So what you can do is you can change the throughput of your table by just a simple command, right? And what will that look like? That is as simple as that, right? And that's it. Compare this to what you would have to do if you are running a normal Cassandra cluster. You would have to think about adding the nodes, removing the nodes, all those kind of things. Pretty much everything is not required. If you don't want this throughput, remember, across all our Cosmos DB APIs, you pay us whatever is the maximum throughput in a given hour. So you can basically, you should take advantage of this rather than provisioning for the peak. This is what happens with normal workloads in the VM-based workloads, right? Here you don't have to do something like that. You pay what you're using at a given point of time, right? And of course, you can do the same thing through the portal too. You can pick up one of, actually it's not this, it is this gentleman, and you can come here. It would have changed. It is 2000 now, so let's make it 6000. So this is the same thing that you can do here too, right? So it's straightforward. You would normally, most probably, you may use the portal, but if that is not the case, you can always use the SQL/SH. Okay. So you have seen how we created an account, how we basically access the data or created the data, how we use the SQL/SH tool or the Cassandra stress tool, or increase or decrease the provision throughput. Now let us see what else we can do here. So what else we can do? The other thing is, the other important thing that many customers have is, I have existing piece of code. What do I need to change, or how does it work? Pretty much everything works the same. So let me walk you through C#. Also, while it is there, let me also address the elephant in the room. Majority of our customers in Cosmos DB use Spark on top of Cosmos DB. So if there are customers who use Spark plus Mongo, Spark plus SQL API, and of course, they want to use Spark plus Cassandra API too. So we definitely do support it, right? So what is required to connect, and I don't know whether that is very visible, so let me try this. Is it a little better? Yeah. So that's, I think, the maximum I can do here. So do not worry about this part. This is just something that I usually do just as a usual stuff for just to verify what I'm running. But here you would see everything remains the same, right? And you are doing usual imports. That works out fine. What does change? What changes, right? There is no change here also. You use the data, basically the connector which is there for the Cassandra, right? That also does not change. The only thing is this extra Cosmos DB library for retry. And I will cover this. What does this do? What is the purpose of this library, right? The purpose of this library, remember, across all Cosmos DB APIs, when you provision for X amount of throughput at a per second level, if you exceed at that particular per second, you will get rate limited. So what we do from the Cosmos DB side, we tell you how much time to wait and when to retry. In normal SQL API of the Cosmos DB, what we literally, the SDK takes care of all this, right? SDK will retry for 9 times without you doing anything, right? In our case, in case of the Cassandra API does not have this concept of rate limitation, but they do have a concept of retry. Actually, they have very extensible retry mechanisms, far more extensible, right? So what we have done is we have created a simple, I will show you the C# version of it, where we basically look at the exception which is thrown, which will be basically rate limitation exception, and then number of times that you want to retry. You can change all those things. That's basically what this particular jar actually does, right? Once you have this, the only thing required is now to provide all the connection information. And then that's it. Hopefully this goes through. And that's it, right? So that is the data which comes in. So that just executed just about now, right? So if you do Spark-based analytics workload on Cassandra, that will also work out of the box. You don't have to do anything specific or magical here. So hopefully that gives you a comfort factor also, that also works out of the box, right? So now let us look at the code. So code, I have it here. So let me just see that part. So everybody can see that, right? So I want to focus on few important things here. So first part is the create key space and everything is just the same stuff, right? It is absolutely, there is no change per se in terms of what the usual stuff that you do with the create key space. What does change, or what changes you should do at some point of time? You should definitely have this extra retry policy, right? What is this retry policy? What does this do? There are 2 parts. So let me just first focus on the retry policy and then other piece, right? This retry policy is nothing but when you get an error on the request, and if it is an overloaded exception, basically try to find out, generate the retry decision. And this retry decision is nothing but it retries for X number of times, right? And this is, there are multiple examples of this across all the APIs, and you can take this in various, and we will publish it if people need it, but this is very established procedure in Cassandra world. People write very complex retry procedures, whether to go to first node, second node, or to drop the consistency level and all kind of things, right? So we are expecting most of the people know. We'll just provide a helper example for people to build off, okay? In case of Spark, we just built a jar because we didn't want people to write again and again. So this is first part. So let's see what, is there anything else, right? Nothing much changes in this world. Only thing which changes, remember, in Cosmos DB world, you need an entity, a container with a throughput. That's the change that you need to do. You need to provide the Cosmos DB provision throughput statement. That's the key part. The second part is the retry policy. Now, also remember that Cosmos DB is one of the few systems which will tell you how much of resources you have used. So whatever RUs that you have provisioned, or request unit that you have provisioned, whenever you execute a CRUD statement, we will tell you exactly how many of those RUs you have used for that particular operation. That remains true with Cassandra API too. So what do we do? With Cassandra world also, we provide a way for you to pick out the request charge, right? And this looks very elaborate, but this is very simple way of saying, if they get me the request charge for a given operation, that's all it is, right? Why would you require this? Let us say you do operations of scans. Scans, their request charges can change. But if you do point read, that request charge will never change, right? So if you want to just have that idea in your mind, okay, for this operation, I spent so much, and for these operations, I spent so much. You would normally, most of our customers either use Microsoft's App Insights or Datadog or other set of tools or their own telemetry to push this information to ensure that they know what they are spending or where they are spending. Okay, so these are the 2-3 changes that you need to do to extract the maximum. By default, out of the box also it will work, because by default what we will do, we will provide you a certain throughput and you can just go along, right? But that is not what you should do. You should actually plan for it. Okay, so with that, what I'll do is I'll switch back to the presentation, and hopefully everybody is still there with me, right? This is very end of the day, right? It looks very simple and it looks very boring. End of the day, we want to make it very boring. We should not be in the front. Database people should not be in the front. So if you're managing Cassandra, you should not be the hero all the time. You should just trust the system to take care. You should demand more of the vendor to do the right thing for you. You want availability you want performance guarantees. You should get all out of the box. You should not be managing this by hand. And that's basically what we're trying to do with the Cassandra API, right? So now, how do you basically work with Cassandra API? As you already saw, it is dead simple. There are 2 ways. You have a new application. New application is very straightforward. You don't have to move the data. In the case of existing applications, you'll need to move the data, right? And I have a good news for you. I have a surprise guest today who is actually working on our MongoDB migration, and I'm holding him also for our Cassandra migration in the future. And he will come a little later to talk about MongoDB work piece. But right now, the way to move the data is that majority of our customers that we worked with have used Spark, because they generally have a Spark running, right? You read from a Cassandra cluster and you push it to our side of the world. As you saw, read, writes, everything works just the same. We will have capabilities, custom tools as part of other mechanisms too. But right now, this is what we have. Okay? So that is basically the usual steps. There are not very many complications that we have seen. There are customers, as you might have remembered in the keynote of Rohan. There's a customer, actually very large, Symantec, basically moved their Cassandra workload to us within less than a month or so, right? Just like that. And they are moving multiple workloads to us at this point of time. There are multiple customers like them in both security, healthcare, and retail, hospitality. All of them are basically trying to get away from the pain of managing large Cassandra clusters. That's basically it. Right? How can we make it better for you? Right? We have partners. If you have specific partners, let us know. If they are not aligned, we can work with them. They get there is a special kind of thing that they can do for you. We can make this whole migration very, very easy. Okay. So by the way, we can also help you. Of course, we know that you are a very small team, but we do tend to go out of the way and help customers. What we can do is help you review your approach, and how, if there are questions around the technology itself, we can answer all of those things. Right? In many cases, we are pretty much part of customer migration right from the beginning, or adoption itself. Okay. What about the cost, right? So I'll address it in multiple steps, right? So first thing, this is in public preview right now. You can create, so there are customers of ours, both in Mongo as well as in Cassandra. They have 10 to hundreds of tables, because we charge at a collection level or a table level. There are customers who basically bundle multiple tables into a database and share the throughput across all those tables or all those collections. Okay. Now this is very important, because then you can save money by just doing this part of the thing. So this is when you consider a new application development or a migration, just think of this one particular way to save money. Right? What is the other way that you can save money? Of course, if you like the service and you want to stick with the service, you can save up to 65% over 3 years. Right? So this is the other offer that we have come up with. It is applicable across all APIs, and it is applicable across all your accounts. So many customers basically think, okay, I have a different subscription for testing and development and so on and so forth. You can bundle everybody's throughput and say this is what my throughput is, and then we can, it's very straightforward discussion. Okay. Of course, no discussion will be complete if you don't compare a vendor, right? If you have noticed, Cosmos DB always had a TCO study where we basically compared the Cassandra by a vendor, other managed service, and us. And even today, that basically holds true. We are going to be very cheap, considering that you will be spending on the licensing, considering that you will be spending on higher provisioning, because you will not be able to provision what you require. You will be only provisioned for the peak, because that's the only way it works. Because if you see the best practices for deploying a large Cassandra cluster, you will have to, first of all, take care of the peak itself. You cannot just say that I will do it on demand most of the times, right? So we are very cheap when compared to on-premises deployment. And of course, when you come to this side of the world, if you run on the cloud too, and there are many of our customers who run on the cloud, we are cheaper there too. We come out about 2 times cheaper at this point of time. The advantage on the cloud, of course, is that customers do not have to pay for the data center and other set of things. But still, we come out cheaper on that front. Okay. Now, I don't know whether you can see this, and I wished I could make it better. This is basically about 110K reads per second. This is one of the many customers who wanted this kind of test to be done. This was done some time ago. And notice there is one very small thing there, which is the latency at the 99th percentile. It's about 5.3 millisecond. This is about 1 KB data, right? And this is what is completely possible out of Cosmos DB without you doing much. So if you really see what I have tried to show you here, if you run the Cassandra stress, and if you provision, the amount of time it takes to provision, to load up the data and run your stress tests is extremely low. So this should give you a lot more confidence to adopt the Cassandra API today, right? With that, what I will do is I will take a break. I have my friend, my colleague, Nikhil, who will basically join in now to talk about the most exciting thing, which is how to move data in MongoDB. I would also request, since so many of you are here, I'm assuming that you are interested in the Cassandra API. If there are questions, I will take the questions a little later, let him finish the exciting part. But please do give us the feedback on that tool too. So thank you very much. I'm available here.
Hello, everyone. It's working. Good. Hi, my name is Nikhil. I work on a brand new service. We've GA'd that. It's called Azure Database Migration Service. What I will like to do is talk a little bit about the service so you guys are aware about its capabilities and how it's built and how you guys can use it right now to do all kinds of migrations. SQL, RDBMS, NoSQL migrations, both. So it's like one-stop Azure native service that helps customers do this. So we'll change a gear a bit. Govind was talking all about the Cassandra. We will support Cassandra in a few months, but we've seen a lot of demand for MongoDB migrations to Cosmos DB, MongoDB API endpoints. And one of the things we wanted to do is make sure that we have a native solution that helps you guys migrate to Cosmos DB and use all the goodness that Govind was talking about. So what are the options you have? The obvious ones are Mongo Dump and Mongo Restore. Everyone knows about that. They're very popular. And those are good. They have been good, but it's, we've seen that it's a little cumbersome in the sense that if you have large estate, tens of databases, hundreds or thousands of collections, it gets very unwieldy to dump and restore and all of and keep doing that till the migration finishes. So then That's the reason we said that, hey, we need to go think about a few other things. Now, Cosmos DB also does MongoDB migrations to its SQL API backend. That's also very popular. And for that, we already have a migration tool that does the actual BSON to JSON conversion and then saves it into document DB, Cosmos DB, which is its SQL API is a JSON store. As if you guys have used it, you would know that. The second, we didn't have a very native solution or a tool till today to do MongoDB to Cosmos DB Mongo API migration. This is a BSON to BSON migration without using the dump and restore. So that's where we came up with the online service offering that helps achieve that. So let's just talk about Azure Database Migration Service real quick, and then I'll have some demos for you guys to see how the service works and how easy it is. So here's Azure Database Migration Service. It's online. It can, as I said, it supports multiple sources: SQL, MySQL, Postgres, Oracle, and Sybase, and all such RDBMSs. And then, of course, we have Mongo that we've just introduced as a first NoSQL source. And we, of course, target entire Azure ecosystem. So you can go to SQLDB or a VM and Cosmos DB for all your NoSQL needs as well. In future, we would also support SQL to a NoSQL migration as well. So if you felt like you wanted to migrate some table make it a document store and push it in Cosmos DB, we'd be supporting that as well. So how is this? Let's just do a quick deep dive into how does the service work and what it is, right? So Azure native service, so you get all the usual niceties. It's got Azure portal presence, it has PowerShell API, it has CLI, which is what I'm assuming you guys would use. A lot of Mongo NoSQL people would use CLI, they're a lot more comfortable. Here's a little deep dive. We can just quickly walk through. The service runs in Azure, it's behind ARM, so it's all secure. You guys are pushing your data in Azure. We wanted to make sure that it goes through all the security and compliance that any other service offers you. So we have ARM authentication that lets you go through that. In the back end, because it's a service, we want to give a reliable experience. We do a bunch of things to maintain state, to make sure that there is checkpointing and there is restartability. So essentially, you do a fire and forget operation, and the service would just make sure that your data ends up where it needs to be. So how does it work? It provisions a migration engine that connects to your network to actually go and access the source. The source can be on-prem or in a competitive cloud, wherever it runs, in AWS or an Atlas. And then it moves the data over your network into Azure. So even though the service runs in cloud, we don't actually see any data, and it's over secure channel. It's all encrypted at rest, and it ends up in the target. Right? All right, so what are the steps? Really, it's as simple as you create an instance of service, you select a source, you select a target, and run a migration, right? Sounds super simple, right? Why don't I just show you how it works? Let's see, let's switch the source. All right, here you go, it's good. As I promised, service has Azure portal present. So here what I've done is I've created an instance of service already. So let's see, let's just walk through what the service looks like. And you could create, here. So I can just show you here. I have done, here's Azure Database Migration Service. You would go create an instance of the service as usual. Right? You choose a subscription that you want to create the service in. You do the resource group. All the same things that you're used to when you work in Azure, right? Location. This is the important part, the virtual network. This is the VNet that you would have selected. You would select the VNet where your source are. So if you have a network You have an on-prem network that runs your Mongo installations. You want to make sure that you have a VNet that has connectivity to your on-prem network, and then you connect a service to that. And you have, like any other SKU, any other service, you have some SKUs of the service which will help you kind of make sure that if you have a dev test workload versus a large-scale migration movement, you would use one of either general purpose or business critical based on the speed and the scale you would want. Let's just go back to an instance of the service I have created and talk about that. So here, let's just go to here. Actually, let me just go back to the service I have here. So once you create the service, you quickly get the usual essentials view, which is you have the resource group, you have your VNet that you've connected. Here I've connected to our CorpNet where I have my source Mongo running, the subscription, the SKU, I have a 4V core SKU, location, subscription, and such. So what, as I said in that chart earlier in the thing, you just create a source, create service, you would connect to your source and target and then do the migration. Now what we've done is we've given the concept of, concept of doing a project where you would kind of plan out your migration and you would kind of figure out all the databases you want to move and then make that project and then run the migration. So you don't have to kind of do this for every single database. So let's just see what a project creation experience looks like. So you would give a project name, say new proj. You would connect, here's the source type that we have. So among other things, let's just do Mongo. Here's the target that I want to use, which is Cosmos DB Mongo API. I'm going to do offline migration. So we support two kinds of migrations. One is offline and one would be live migration, which is online. So it'll keep your source and target in sync. It'll be shortly available in the portal, but if this time permits, I have demo of that to share with you guys. So that's it. I would just create a project and I would start selecting the source. Let's just say Azure. That's it. And this is my Mongo source. This is where I'm running Mongo. Here's my Mongo port. And I would save it. If I haven't typoed it, it should just connect to this thing. Well, while it's connecting, what it did is it went and gathered all the information on the source about your databases, collections, the collection size, shards, shard keys, everything. You'll see why it helps. Here, you can just select the target, which is Cosmos DB target. Select the subscription where you have your account created. I have one here. The service would go scan the subscription and figure out all the Cosmos DB accounts you have. I have couple. So let's just say, here's the thing. It'll autofill up your connection strings and all of that, so you don't have to kind of deal with it. It's kind of nice and simple to do that. I'll save it. The service is now connecting to your target Cosmos DB account. It's getting all the RUs, all the collections, if you have provisioned any, and then it's trying to match up with your source. Like, hey, on source I found these, on targets I don't have it. So here it already found that on target you had some collections which matched, right? And if you can either re-sync these collections up or choose not to migrate to them. In our case, let's just say I will migrate to just this one guy. It did not find this. So what it does is it's going to go and create this database for you. And you can leave what we have as part of a service where Govind spent some time on the RU, how do you manage RUs and such. The nicety of the service is it will go and figure out the smart defaults. So what it does is it figures out the size of your collection and gives an approximation of how many RUs it might need, right, based for that. Here, this feature is for doing a shared RUs at the database level, which is what Govind was talking about, which is in preview, but we've kind of exposed it for our customers. So you could either leave this, fill it, or leave it blank. It doesn't matter, because you can then still go ahead and configure your RUs at collection level if you feel like. So here we found one collection. We've defaulted it to 1,000 RUs, because we felt that it's such a small collection, we really don't need more RUs. So that was a smart default. I have ability to give shard keys, which is generally a good thing. So that way I can space out my collections, and I would save it. That's it. So what I did is connected to my source, connected to my target, chose what database and collections I wanted to migrate. I didn't have to deal with RUs. The service took care of it. And I would just give this activity a name, just say new run one. And here's a nifty little feature that you guys would appreciate if you use. It's called boost RUs. What the service does is it figures out when you start migrating that if the data set is super large, it would go and boost the RUs to maximum available per collection to do the fastest migration. So that way you don't get throttled on the target, because you may not know all of these things when you do it. So the service kind of starts figuring it out for you guys, right? And what it does is, of course, you pay for RUs. If you leave it up, it's going to charge you. The meter keeps running. After the migration, it brings it back to your default level, right? And that's it. I just hit run migration. So what it's doing is now it's doing all kinds of calculations on the source and target to start the migration. It's figured out it's got 1,000 documents. It's batching it. It's trying to, all of this is doing streaming, right? So it's actually connected to the source and moving it to target. There, boom, we're done in 14 seconds. So, it was just 1,000 documents. But the point is, none of the restore, none of the dump, none of that happened. It just connected to the source, figured out the best batching mechanism. That's something that we worked really hard to figure out. How do you start batching, at what indexes, what spaces, what key spaces do we start batching these things, so that way we can move these things super fast to the target. So that is how you would just migrate your databases and collections at scale with reliability to MongoDB API exposed by Cosmos DB, right? Another thing about the service is it's fault tolerant and it's got checkpoints. So let's say you had 10,000 collections you are migrating, and if you had a network blip, if your source went out or if your target went down, the service would know till the batch that was committed and restart from that batch level, right? We will give an option of letting customers know that if you want up to a batch level, or if you want the entire collection resync, because guaranteeing consistency would be hard at that point, because your source is live. We won't be able to make that decision. But if you felt that, hey, it was not live, you still want us to start from the batch level, we can pretty much do that. So all in all, this takes care of your dump and restore at a super large scale, and it has intelligence to make use of the best features of Cosmos DB when it comes to migrations. All right, so this was one time. People obviously want to talk about what happens in case of my source and target are up, live migration. I will attempt to do that here. So here's my source. It's in a Mongo mean app, and it's connected to my local host. I'm running it on port 3001. I have these many articles here. Essentially, these are my documents, right? And here's my another source, the same app connected to Cosmos DB. And you can see here's my Cosmos DB, here's my database, essentially, here's my collection, the articles, and it's got nothing in it, right? So what we'll do is I will do migration, and so all of this I'll do using the command line app that I've written on top of DMS. So, this is where you guys will kind of use this as to automate stuff and keep stuff running. So I have, right? So let's see if things are gonna work out for me or not here. So here, this is my source. Here's my target. I've kicked off DMS service. I call the API to run the migration activity on the instance that is connected to the source and target. I did the UI first so that you guys could figure out that's how the flow works from UI, but you can totally use, I used an API and just wrote the program here, and there you go. So now, here's my source, here's my target, it's all good, here's the documents. Now, the fun part would be now, what if I want to go and change some stuff on the source and see that work on the target? So let's just go here. Let's see how this goes. Let's go and delete this guy. Okay, not authorized. Let me just re-sign into my app again. Sign in. Let's see. Okay, it signs me in. I go to the articles. Let's go delete this guy if it allows me to. Okay, here I deleted one article. How about I delete this guy also, if it allows me to. Sometimes it. Okay, I deleted 2 articles. What happens here? Let's just see that. Boom, live changes. Source, target, in sync. Super fast way of doing it. So what this would do is you can go and migrate your Mongo workloads while your source is running. Get confidence that Cosmos DB is tuned to the levels you want to guarantee your customers, and not have to worry about syncing at all. No one does this. This database migration service is the first service that will let you do that. There is no other tool or a vendor that will give you this ability to keep source and target in sync in real time. I guess with that, I am going to end the thing, and I'd be happy to take questions. Govind, what source do we have to go back to? 8. Oh, thank you, Shamik. The service is in preview, and we have signups open for everyone to come do that. You can see the announcement on the Cosmos DB site. It's called DMS preview. Once you sign up for it, we'll just whitelist your subscriptions, and this capability will just light up in your portal. You don't have to do anything. The service is free. You don't pay for it, and you can do these migrations all day long. We've had, till date, for RDBMS sources, over 80,000 databases migrated. So we do the same thing with databases as well. So live migration of source and target. And these are banks, insurance companies, small guys also, mom and pop, which do not want to use an IT vendor. They can do it self-serve because it's that simple for people to use. Thanks.
Thank you. I think this is amazing.
Questions?
We have finished before time. Yeah.
So the destination on this is going to be read-only, I would assume, or while you're replicating this, or while you're migrating?
Yeah, we don't do.
Do you want to repeat the question?
Yeah, the question is, will the destination be read-only? Will it be read-only, and do we replay the changes back onto the source? Yeah, we don't do two-way sync. It's one-way sync. Yeah. From ADF? How is it different from ADF? Yeah, so ADF is a batch ETL movement system. It doesn't do that well with time series. They are trying to work it out. And in ADF, you would have to write all sorts of connectors. You have to write your own code unless there is a third-party vendor that does that understands some of these natively.
And there is no real-time migration yet. There is nothing like that.
Yeah.
Not probably.
Not there. So ADF is a good data integration pipeline. It doesn't solve the migration challenges, right? They kind of are very similar in flavors, but there's the nuances, data integration on a nightly basis versus migration, which takes care of. So in this case, one thing I didn't mention is when we do the migration, we migrate everything, indexes and views and functions, and other than just documents. So it's not just document migration. Schema movement as well. So when it does, it also smartly figures out what indexes it doesn't need to migrate, because document DB auto indexes everything. Cosmos DB auto indexes everything by default, so you don't need some of the indexes on the target. They're not compatible. Yes, you're right. So that is what I call data integration workflow, and you're right, Data Factory is the right service to do that. But when you're thinking about large-scale migrations, like banks moving their entire Mongo clusters over to Cosmos DB, that's when the services like DMS, Data Migration Service, makes it easy for them.